We'll be working on section 4.3 of our course titled Linear Functions, Slope and Equation of Lines. So as you can see, this is just a part one. So in particular, we'll be working on lines, okay? We'll formally define what a line is and what a slope is, and then introduce several forms of equation of a line, okay? So let me start with the following picture. So in here you see Euclid, okay? So this is a Greek mathematician, okay? And Euclid here is considered to be the father of geometry, okay? And during his time, he um, created or he authored the book Elements. Okay, it consists of 15 books. You can read it here, but only 13 was actually, or only 13 books were authored by Euclid himself. The other two books, book 14 and book 15, um, they were written by other mathematicians. Okay, so the first 13 books, they were authored by Euclid. And this book here, Elements, it contains all the things that we know in the Euclidean geometry. Okay, that's why he is considered the father of geometry, because everything that we know in Euclidean geometry can be traced to Euclid. Okay, so all the definition, propositions, theorems, corollaries, they were all, most of them were uh, proved or were stated by this mathematician Euclid. Okay, so um, why am I introducing him to you? Because of course the definitions that we're going to use will be coming from him. Okay, so for example, let's start with the following. So in the book 1 of Elements, definition number 2 there, you see, you will read a line is a length without breadth. Okay, so this means that a line is just a length with width equal to 0. So that's without breadth. Okay, and then definition 4 of the same book, okay, defines the following. A straight line is one which lies evenly with points on itself. Okay, so you have a straight line and you have several points um, on that straight line, and there is a property. Okay, so a straight line is one which lies evenly with points on itself. Okay, now our definition is the following. A line is the graph of a linear equation in two variables, say the variables x and y. So we have calculated or we have solved some linear equations before, okay, in one variable, or in here we are going to use two variables, say x and y, and the graph of that equation, okay, will be a line. Okay, now let us look at this. So this is a line. Okay, this is a line here, and let us say, let's take some points, 1, 2, 3, and 4 points on this line. Okay, now let us consider, suppose there's, of course, if you are on the Cartesian plane, you will have some coordinates for each of the point here. Okay, and then let us say, let's construct this right triangle, okay, with hypotenuse this point and this point. And because this is a right angle, this is just horizontal, this is just vertical, and this is a right angle here. Okay? And then you can construct this right triangle also, and you can also construct this right triangle also. So for this right triangle, you have this point and this point as two vertices. This is the hypotenuse. This is one of the base of the triangle, And then this is the other base of the triangle, which we usually call the altitude or the height of the triangle. And similarly for this. Okay? So, the definition here, the definition that you see here, a straight line is one which lies evenly with points on itself, um, can be interpreted as follows. So you have this right triangles. Let us take the length of this base here, and let us take the length of this height in here. And let us call this length here run, and then this height here the rise. Okay? And then you can also take this base here, you label it run, and then in here you label it rise. Or maybe this guy here and this guy here. Okay? This is the run, this is the rise. So essentially, what we're saying when we say run, it's a horizontal line. It's a horizontal line segment, to be more precise. And arise, it's a vertical line. Okay? But more accurately, a run is just the distance of this vertex here or this point here towards this point here. Okay? It's a horizontal line segment. Okay? And you calculate this distance from this point to this point, or maybe from this point to this point. Okay? And then the rise, it's the distance from the other point on the line towards to this newly created point. Okay? The other vertex, the third vertex for your triangle. Okay? Now, what I'm saying in here is that you have a run here, you have a rise here, and this has its corresponding run, this has its corresponding rise. And I'm not saying that this run here is the same run in here. This run here, it looks like it's shorter than this run here. And then this rise here, it looks like this is longer than this rise here. And definitely, if you look at this, you have this run here and then this rise here. Definitely, the run here is way shorter than the other runs. The rise here, it's way shorter than the other rises there. Okay? But what we can get from this is that if you compute this ratio, rise over run, so you compute rise over run in here, you compute the rise over run in here, you also compute rise over run in here, okay? If these points here lie on the same line, this ratio rise over run will remain the same, okay? And this ratio rise over run measures the steepness of the line, okay? So you have several rise over runs, okay? If these points lie on the same line, you calculate the ratio, rise over run. Whatever 2 points you get, they will remain, or the ratio will remain the same. So even if, say, I consider this point here and this point here, and then I'll have this right triangle here. Of course, this guy here will have some measure run, and then this guy here will have some measure rise. Okay? If I get the ratio rise over run, it's still the same rise over run with the other rise over runs. Okay? So it's fixed if these points lie on the same line. Okay? It's a fixed ratio, and that ratio measures the steepness of the line. Okay? Now, since this ratio is fixed, okay, we can give it a name. Okay? The name of that ratio is called the slope of the line. Okay? So this rise over run in here, it will be called, or it is called, the slope of the line. Okay? So, as I have mentioned, this line here and all the things that you can see on this particular part of the screen may be on a single Cartesian plane or a single rectangular coordinate plane. So let us label some points, okay? Let us give the coordinates of the points in here. So let P1 with coordinates x1, x2, x1, y1, and P2 with coordinates x2, y2 be two distinct points. Okay? So distinct points, it means you can have the following. If x1 not equal to x2, okay? If x1 not equal to x2, the slope m of the line L containing these 2 points here is defined as follows. Your m will be equal to y2 minus y1 over x2 minus x1. Okay? Let us look at this formula and let us go back to this. For example, let's take this as our P1. P1 in here, this is your x1, y1. And then here, let's take this as our P2. This is your x2, y2. And take note, this is a vertical line here, which means if you're on the Cartesian plane or rectangular plane, if you have a vertical line, it means the x-coordinate remains the same. Okay? The x-coordinate remains the same. So in here, if I consider this point here, this has x-coordinate equals x2. On the other hand, you have this horizontal line. And remember that if you're on the horizontal line, it means your y-coordinate remains the same. So the y-coordinate here, it's just your y1. Okay? And therefore, in here, what do you see? Here, your rise or your run is just the difference between the x-coordinates. And since this x2 here, it's to the right, okay? And then in here, it's to the left. Let's say the run, it's equal to your x2 minus x1. Anyway, this is bigger. And then for this, you have the rise. This rise in here, since x2 are the same, the x2 here, or the x-coordinates are the same, we compute the rise to be the difference between the y-coordinates. And since this is higher than this, the rise will be equal to y2 minus y1. Correct? And rise over run, it means you have y2 minus y1 over x2 minus x1. Correct? So y2 minus y1 over x2 minus x1. That's your rise over run. And that's precisely the formula that we see in here. Okay? And as a shorthand computation, suppose this is your, say you have your P3 in here. This is your P3, x3, comma y3. And then this is your P4, x4, comma y4. The rise over run will be calculated as y4 minus y3 divided by x4 minus x3. Take note how this ratio was written. So in the numerator, your minuend here, it's y4. It's coming from the point 4. So if you write your denominator, the minuend, okay, the x-coordinate must be coming from point 4 also. That's why we write here x4 as the minuend. Okay? So y4 minus y3 over x4 minus x3. So I chose this P4 to be the minuend for the ratio. Okay? If I choose P3 to be the minuend of the rise over run, then we can do that for as long as you remain consistent. This guy here will be the same as. So I am considering now P3 as my minuend, meaning I will write Y3 as the minuend. So the subtrahend will be your Y4. So Y3 minus Y4. And since I use Y3, okay, this Y3 came from P3, my denominator, the minuend must also come from point 3. So the denominator will be x3 minus x4. Okay? And if you calculate this, you will get the same ratio. Okay? You will get the same ratio. And that should be the case because that's a property of this particular line. Okay? That's a property of this particular line. This guy here is the slope of this line, and therefore, however I write it, for as long as it's consistent, okay, my minuend will be coming from point 3, okay? Or in here, my minuend came from point 2, okay? As long as that's consistent, the ratio will remain the same, okay? So that's the formula for our slope. Y2 minus y1 over x2 minus x1. And I'm saying, just to emphasize the discussion in the previous slide, this is the same as y1 minus y2 divided by x1 minus x2. Okay? So this time I'm getting 0.1 as the minuend. That's why I started with y1 here, and I have to write x1 in here. In here you have y2, and then in here you have x2 as the minuends. Okay? So that's the slope of the line L containing P1 and P2 if x1 and x2 are not equal. Okay? If, however, x1 and x2 are equal, okay, then the line containing P1 and P2 will be a vertical line. Same x coordinates. And remember, same x coordinates, you have vertical line. So x2 here, it's a vertical line. Only the y coordinate changes. Okay, so that's a vertical line. Only the y coordinate changes, the x coordinates remain the same. And in that case, okay, in that case, our slope will be said undefined. Okay, and it is undefined if we are going to use this formula. X2 equals x1, it means the denominator will be 0. So it's undefined. Okay, so for vertical lines, the slope will be undefined. For non-vertical lines, the slope will be calculated using this formula. Okay? Question? Okay. So in here, you have your P1, X1, Y1, P2, X2, Y2. You have this line L. So of course, Y coordinate here, it's Y1. This is the Y coordinate, Y2 for the P2. This is the X coordinate for P1. This is the X coordinate for P2. You have the run, you have the rise. Your M is equal to rise over run, which is equal to Y2 minus Y1 over X2 minus X1. Okay, provided X1 and X2 are not equal. And if you have equal X coordinates, therefore you have X1 here, you also have X1 here. Okay, so only the Y coordinates change. You have here a vertical line, and the slope is undefined. Okay, question so far? Okay, so let's look at some remarks, okay, regarding this line, particularly the slope. The slope m of a non-vertical line measures how fast the change in y when x changes from x1 to x2. Okay? In notation, the slope is given by this. You have delta y over delta x. Here, this triangle here, it's the Greek letter delta. Okay? So delta y over delta x. And this is also called the change in y over the change in x. Okay? And this guy here, it's the average rate of change of y. So take note of this phrase here. Average rate of change of y. Okay? Now, if the slope, or if m is the slope of a non-vertical line L, then any two distinct points on L can be used to find the value of m. Okay? Just like I mentioned uh, in this part here. I can use this point and this point, compute rise over run. Okay? I can use this point and this point, compute rise over run. I still get the same value. In here, I have this point and this point. I'll compute rise over run. I'll still get the same value as the other pairs here. Okay? So I can use any 2 points as long as they are distinct, okay, to find the value of m. Okay? It means if P1, P2, and P3 here are three distinct points on L, then m can be calculated as y2 minus y1 over x2 minus x1. It can also be calculated using y3 minus y1 over x3 minus x1, or y2 minus y3 over x2 minus x3, etc. As long as you are consistent, y2 minuend, x2 must be minuend in the denominator. Here, y3 and then x3 here. Here, y2 and then x2 here. And all other combinations, as long as you use the coordinates of one point to be your minuend and then the other point to be the subtrahend. Okay? For example, find the slope m of the line containing the points 2, 6 and 4, -2. Okay? So this is your first point. This is your second point. Okay? Slope of m, it is equal to this ratio here. So notice 6 here, it's the y coordinate of this point. So I must use 2, the x coordinate of this point, to be the minuend of the denominator. And that's what you see in here. So anyway, you have 6 minus -2. So 6 minus -2 all over 2 minus 4. So 2 minus 4. And if you calculate this is equal to -4. Okay? Or you can use this point as the minuend for the numerator or denominator. As you can see here, the minuend, it's -2. That's your -2. And the denominator, the minuend, it's 4. This is your 4. So you have -2 minus 6. That's that. And then 4 minus 2. That's this. And you get -4 also. Okay? Question? Next problem. Show that the points 1, 1, -1, 3, and 5, -3 lie on the same line. Okay? Or we call it collinear. We call it collinear. So for example, you have this point here, and this point here. Okay. So this is what we want to see. They must lie on the same line. Okay. So what we're going to do. So what we can do is to choose 2 points, okay, on this line. Say this point here and this point here. And then we calculate the slope of the line generated by these 2 points. And then we use again 2 points, okay? We again use 2 points, okay? Of course, the third point, you have to use it, and then just choose any of the other points of the first pair that you used or that you have used, okay? So maybe this point here and this point here. And then you calculate the slope of the line generated by these 2 points. If the slopes that you've calculated are equal, and since they have a common point, it will mean that the 3 points will lie on the same line. Okay? It means it will lie, or they will lie on the same line. So that's what we're going to do. Okay? So it is enough to show that the line L1 containing 1, 1 and negative 1, 3, and the line L2 containing 1, 1 and 5, negative 3, so this point and this point, and this point and this point. So it's enough to show that their slopes are the same. Okay? So if we calculate that, the slope of L1, so this point and this point, as you can see, I used 3 as the minuend in the numerator. That's the y-coordinate of this point. So I have 3 minus 1 for the numerator. For the denominator, I must use this negative 1 as my minuend. That's why you see negative 1 minus 1 here. And if you calculate this, you will get negative 1 as the slope. So the slope of L1 is negative 1. For L2, here, and this point, in the numerator, I have negative 3 minus 1. So my minuend is this, the y-coordinate of this point. That's negative 3. And therefore, the denominator in here, I must use that 5 as the minuend. So minus 3 minus 1 all over 5 minus 1. And you calculate, it's still equal to negative 1. Okay? And because of that, the 3 points are on the same line. Okay? Question? Okay. Now, let us have more remarks. So let L be a non-vertical line and let M be its slope. Okay? If M is positive, then L is slanting upwards from left to right. Slanting upwards from left to right. So it's something like this. Slanting upwards from left to right. Okay? If M is negative, then the line L is slanting downwards from left to right. So slanting downwards. So left to right and then downwards. Okay? So again, if M is positive, okay, if the slope is positive, slanting upwards from left to right. If slope is negative, slanting downwards from left to right. And if M is equal to 0, then you have a horizontal line. Okay? Horizontal line. Remember that if you have a horizontal line, you have the same y coordinates. Only the x coordinates change. So if you have the same y coordinates, say y1 equals y2, in the numerator, you have y2 minus y1, but they are equal, so it must be equal to 0. I mean, y1 and y2 are equal, so the difference, y2 minus y1, must be equal to 0. So slope is equal to 0. Okay? So graphically, we have that. Okay? Graphically, we have that formula, or we have this um, illustration. Okay? Question? Okay? Now, our interest at this part is to sketch the graph of the line. Okay? To sketch the graph of the line given some information. Okay? So, for example, according to the first postulate of the book 1 of elements, let it have been postulated to draw a straight line from any point to any point. So you are given the point P, the point Q, you can have this line here. You can draw that. And postulate 2 tells us that, and to produce a finite straight line continuously in a straight line. So you have this straight line here. You can produce this straight line here. And you can produce longer straight line. And you can produce longer straight line. Okay? On this particular line that has been produced in the previous step. And eventually, you will have this line here, which extends from, say, let's just say negative infinity to positive infinity. Okay? So postulates 1 and 2 of the book of elements in book 1. Okay? So that's what we're going to do. We need 2 points, and then we can draw the straight line. Okay? We need 2 points, and we can draw the straight line. Now, let us consider this example. We want to sketch the graph of the line having a slope m, which is equal to 2 over 5, and contains the point 1, 2. Okay? We are given 1 point only, but we are also given the slope. So how are we going to sketch the graph of the line? We use the fact that slope m, it's rise over run. Okay? We use the fact that slope m, it's rise over run. Rise over run, but the slope m, it's 2 over 5. So we can have several possibilities. In fact, we have several ways in drawing or in sketching the graph of this line. Because in here, this means we can take rise equals 2. They are both in the numerator. And take run equals 5. Okay? We can also take rise equals negative 2 and run equals negative 5. Which means rise over run, it will be negative 2 over negative 5, and that's positive 2 over 5. Correct? Now, what's the point of using positive and negative? Actually, what's the effect of using positive and negative? For the rise, if it's positive, you move upwards. So for rise equals 2, it means you move 2 units upwards. For negative, okay, rise equals negative 2, your motion will be downwards. So rise equals -2, you move 2 units downwards. For run, you move to the right if it is positive, or to the left if it is negative. Okay? So again, for rise, positive, going upwards, negative, going downwards. For run, positive, going to the right. For negative, going to the left. And however you write the combination for 2 over 5 as rise over run, you should get the same line, because that's a property of this line. The line must have slope 2 over 5. Okay? So we combine these two information here, the point 1 comma 2 and the slope equals 2 over 5. So this is your point 1 comma 2. Okay? And then we run 5 units. So the x coordinate it's 1. You move 5 units from 1. 1, 2, 3, 4, 5. So you are at this point. Okay? And then you run 2 units. You rise 2 units. Y coordinate it's 2. You move 2 units upwards. So this is that point. Which means this point here has coordinates 6, comma 4. So from 1, comma 2, you run 5, then you rise 2, okay? You will get this 6, comma 4. You can also do this. Instead of running first before rising, you can start with the rise and then the run. So in that case, for example, you rise first, 2 units, and then you run 5 units. You will still get this same point. Okay? So you can rise first and then run, or you can run first before rise. You will get the same point. And now since we have 2 points, 1, comma 2, 6, comma 4, you can now draw the line using the postulates that we saw in the previous slide. Okay? Question. Okay, so let's consider our next example here. Sketch the graph of the line having slope equals -1/2 and contains the point 0, comma 3. So just like before, we consider now rise over run, that's -1/2. But take note that this -1/2 can be written in other ways. You can write this as -1 over 2, or you can also write this as 1 over -2. Okay? So one option for rise, it's -1 and run equals 2. The other option is rise equals 1, run equals -2. Okay? And there are more options. There are infinitely many more. How? Take note, your -1/2 can also be written as -2 over 4. This is still -1/2 when you simplify, which means your rise can be -2, your run can be +4. So there are infinitely many choices. Okay? And of course, to simplify our computation, we just use what's already there. Okay? So we choose this -1/2 instead of -2/4 or instead of -3 over 6, etc. We use this guy here. And therefore, we just have two choices, -1 over 2 or 1 over -2. Okay? So, here we can take rise equals -1 and run equals +2. So rise over run, it's -1/2. Others, you can also take rise equals 1 and run equals -2. But we'll use this first here. So you have the point 0, 3. That's the given point there. So rise equals -1. It means we will go 1 unit downwards because we rise -1. And then run equals 2. We move to the right 2 units, which means we have this rise. So we go down here. And then we have this run. We go to the right at this point. And therefore, this point will be 2, 2. And therefore, we have 2 points. We have this line here. Okay? Or maybe you can do this. You run first before rising. You'll still get the same line. Okay? Question? Okay? So that's how we sketch lines. Of course, if you are given 2 points, that will be easier because you already have the 2 points. Just get your ruler, draw the line passing through those 2 points. Okay? Now, this is the geometric part. Okay? Let's go to more analytic part. Okay? Let us try to write the equation of these lines. So you are given 2 points, or you are already given a line geometrically, this line here or the other lines in the previous. The question is, how are we going to write it using variables, using the 2 variables, x and y, etc., if there will exist 2 variables in the equation. Okay? Of course, there's a possibility that there's only 1 variable in the equation and you still have a line on the Cartesian plane. So for this part, we are interested in finding equations of a line. And there are several ways. There are several forms that we can use to write the equation of a line. Okay? But let's look at the first line here, the vertical line. So if a vertical line contains the point x0, y0, then its equation is x equals x sub 0. So you only have one variable, the variable x. Like I mentioned earlier, 2 variables or possibly just 1 variables. And those cases where there's only 1 variable, they are special cases. Vertical line, it means x coordinates remain the same. So we'll just have x equals dot x coordinate. Particularly if the line contains this point, x0, y0, then the vertical line can be written as x equals x sub 0. Okay? Or maybe we have a horizontal line. If the horizontal line contains the point x0, y0, then its equation is y equals y sub 0. And again, you only see one variable here, the variable y. But horizontal line, we said that the y coordinates remain the same. Only the x coordinates change. So we can just say y equals fixed to y sub 0. So this is your horizontal line. Okay? But what if we don't have horizontal or vertical lines? Okay, so let's start with this. The point slope form. If a non-vertical line L has slope m and contains the point x0, y0, then the equation is given by this. Y minus y sub 0 equals m times x minus x sub 0. Okay? Y minus y sub 0 equals m times x minus x sub 0. It's called point slope because you are given a point and a slope. Okay? Now, what if we are given 2 points instead of just 1 point and a slope? So in here, suppose the non-vertical line L contains the points x0, y0, and x1, y1. The formula is given by this. Y minus y0 equals this ratio, y1 minus y0 over x1 minus x0 times x minus x0. And look at this ratio here. This ratio here is actually the slope. That's your m there. It's just that it's not explicitly given, so you calculate that slope. And that's this guy here. Correct? So you are given 2 points, non-vertical line. So 2 points on a non-vertical line L. Then the formula will be y minus y sub 0 equals y1 minus y0 over x1 minus x0 times x minus x0. Okay? Let's have this example. Give the equation of the line having slope -2 and contains the point 2, 6. Straightforward. We write the equation y minus 6 equals -2 times x minus 2. -2, this is your slope there. And then y minus 6, because your y coordinate here is 6. X minus 2, your x coordinate here is 2. So y coordinate is 6, x coordinate is 2. So straightforward. Okay? For the other example here, give the equation of the line containing the points 4, 2 and -1, 3. So this time you are given 2 points. Again, substitution. We use this as our x naught, y naught. That's why you see here 2 and 4 here. But anyway, the equation will be y minus 2 equals 2 minus 3 over 4 minus -1. So this is the point for our minuend. That's why you see 2, 2 minus 3. So 2 minus 3. And then the denominator here, so we use the x coordinate of this point for our minuend. That's why you see here 4 minus -1. Okay? And therefore, multiply it now to x minus 4. And in here, we simplify. So 2 minus 3, that's -1. 4 minus -1, that's 5. So we simplify this as -1 over 5 times x minus 4. Okay? So we go back to this first example here. So again, this is your slope, and that's the slope here. Okay? And then, of course, this is the point we use for this and for this. So point slope form. So if you don't remember, of course, it's understandable if you don't remember it yet, but the point slope form will be this guy here. Okay? And for the 2-point form, you will have y minus y2 or y minus y0, y minus y0 equals, you have y1 minus y0 over x1 minus x0, x minus x0. And again, since this guy here, it's the slope, you can interchange your 0 and 1 as subscript. Okay, so this guy here, you can replace this as y0 minus y1 divided by x0 minus x1. And of course, you can use y1 here, but if you use y1 here, you must use x1 in here. Okay? Questions? Now, there's another way to write this equation. We have this, the slope-intercept form. So if a non-vertical line L has a slope m and y-intercept b, then the equation of L is given by this, y equals mx plus b. Now, we have another term here, y-intercept. So what is this y-intercept? So suppose this is your Cartesian plane, okay? And suppose this is your line. The intersection of the line and the y-axis will contain the y-intercept. This point here, this will have coordinates 0, comma, b. That b there, it's your y-intercept. Okay? And this guy here, you know the slope? Y equals mx plus b for the equation of the slope-intercept form, or for the equation in slope-intercept form. Notice, if you have your x equals 0, that's the 0 there, m times 0, it's just 0. So you will have y equals b. That's why 0, comma b, it's a point on this line. So that's your y-intercept. It's the y-coordinate of the point of intersection of the line and the y-axis. And of course, if you're going to ask about this point of intersection here, it's called the x-intercept. This time, the y-coordinate, it's equal to 0. The x-coordinate, let's just label it as a. Okay? So this guy here, y-intercept, and then this guy here, it's your x-intercept. Okay? So you can calculate the y-intercept by setting x equals 0. You can calculate the x-intercept by setting y equals 0. Okay? So, find the slope and the y-intercept of the line if its equation is given by this. So you have to write this equation in this form. Correct? Meaning you isolate the variable y. So if we do that, this guy here, we can write it as 2y equals negative 3x plus 8. So we move this 3x to the side. Then we divide everything by 2. So you will have y equals negative 3 over 2x plus 8 over 2. And 8 over 2, it's just equal to 4. Correct? So this guy here is equivalent to this equation. So this is the slope-intercept form of this line here. Which means if this equation can be written in this form, obviously this is your slope. It's negative 3 halves. And the y-intercept, it's equal to 4. Okay? Slope, it's negative 3 halves. Y-intercept, it's equal to 4. Okay? Question? Now, another form, we call it the general form. So the general form of the line is written in this way. Ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. There must have at least one variable in the equation. Okay? So this guy here, this is in general form. Okay? This guy here is in general form. Now, this term here, okay, this term here, general form, is actually not it's not being used the same way as in other references. Okay, you will find that in some references, this guy here, it's called the standard form, and the general form is written in this way, meaning the right hand side, it's always equal to 0. Okay, therefore if the constant is non-zero, it will be on the same side as the variables. Okay, so sometimes we call this the standard form, and this is the general form. But for our course, let's just call this the general form. So in any case, we can interchange the term general form or standard form for this. Okay? Question. So let's sketch the graph of this line 3x minus 6y equals 12. Okay. So remember, when sketching the graph of a line, we only need 2 points. Okay. Once you have the 2 points, say this point here and this point here, you can draw the line passing through that point. So we just need 2 points whose coordinates satisfy this equation. Okay? The easiest way to get 2 points, okay? The easiest way to get 2 points on a given equation of line, okay, is to find the intercepts, the x-intercept and the y-intercept. Okay? The x-intercept and the y-intercept. So we only need to find 2 points satisfying the equation. We take in particular the intercepts. So for the x-intercept, we set our y to be equal to 0. Okay? Let me go back to that slide where I describe x-intercept and y-intercept? This guy here. X-intercept is when y equals 0. Y-intercept is when is when x equals 0. So for the x-intercept, we set y equals 0, and then we solve for x. For the y-intercept, we set x equals 0, and then we solve for the y. So that's what we're going to do for this. For the x-intercept, we let y equal 0. So if this is 0, you'll just get 3x equals 12. And therefore, x equals 4. Okay? Which means the point 4, 0 is on this line. So now we have 1 point. For the y-intercept, we now let x equals 0. And therefore, we will have minus 6y equals 12. Or y equals negative 2. Which means the point 0, negative 2 is on this line. Okay? So now we have 2 points. All we have to do is to plot them and then draw the line containing those 2 points. 0, negative 2 is here, 4, 0 is in here. Okay? Questions? Now, let's talk about parallel lines. Okay? Two lines on the plane are said to be parallel if they do not intersect. So for example, you have this line and then you have this line. Even if you extend this from negative infinity to positive infinity, same is true with this, negative infinity to positive infinity. If they do not intersect, then we say they are parallel. And by the way, by this we mean we are on the Euclidean plane. Okay, the Euclidean plane. Now, if it so happens that you have this line and then another line which intersects the other line, of course, these two lines are not parallel. We say that they are intersecting. So there are only two possible cases, at least, if you have two distinct lines. Okay? One is they are parallel. So you have two distinct lines that are parallel. Or the other case is you have two distinct lines that are not parallel. They must intersect. Okay? One helpful theorem for us to determine whether two lines are parallel is the following. Two non-vertical lines are parallel if and only if they have equal slopes and have different y-intercepts. So it means you need to write the lines in slope-intercept form. What's the slope-intercept form? Y equals mx plus b. So suppose you have line 1 with equation y equals m1x plus b1. Line 2 with equation y equals m2x plus b2. So you have two lines. These two lines here, L1 and L2, are parallel. L1 and L2 are parallel if and only if and only if M1 equals M2 and B1 not equal to B2. Slopes are the same, y-intercepts are different. Okay? For example, show that the lines given by the following equations are parallel. So you have two lines in here, L1 equals 3x minus 2y equals 5, and L2 equals 9x minus 6y equals 1. So in order to find, or in order to determine whether they are parallel using this theorem, we have to write each line here in slope-intercept form. Okay? So for example, for this, we can have 3x, or we can have minus 2y equals minus 3x plus 5. So we move this 3x to the other side. And then we divide everything by 2. You will get y equals, so negative 3 divided by negative 2. So you'll just have 3 over 2x minus 5 over y. 5 over 2, I mean, minus 5 over 2. That's for line 1. For line 2, we move this 1 to this side. We will have 9x plus 1. This is equal to 6y. Then we divide everything by 6. So you will have 9x over 6 plus 1 over 6 equals y. But this 9 over 6, it's exactly 3 over 2. So let's just write this equation here as y equals 3 over 2x plus 1 over 6. So they are now in slope-intercept form. Okay. Therefore, we have the following. So written in slope-intercept form, we have this L1 written this way, L2 written this way. And observe, the coefficient of x here, it's 3 halves. The coefficient of y here, it's 3 halves. Same slope. The y-intercept here, it's negative 5 halves. In here, the y-intercept, it's 1 over 6. Different y-intercepts. Both lines have the same slopes, but have different y-intercepts. And therefore, they are parallel. Okay? Find an equation of the line containing the point 2, 1 and is parallel to the line 2x plus 5y equals 1. So in here, you have the point 2, 1. If we want the desired line to be parallel to this, we need the slope of this line and copy it and use it for the desired line. Which means this guy here, we write this in slope-intercept form. You will have 5y equals negative 2x plus 1, or y equals negative 2 over 5x plus 1 over 5. Okay? That's the slope-intercept form. So y equals negative 2 over 5x plus 1 over 5. So we get the slope of this y here, or of this line here, which is negative 2 over 5. Okay? And then we use it. We have a point, we have a slope, we can find the equation of the desired line. The equation will be this. So the slope of the desired line is also negative 2 over 5. If the desired line contains the point 2, 1, then the desired line has this equation. Y minus 1 equals negative 2 over 5x minus 2. Negative 2 over 5 times x minus 2. Okay? Now, are we sure that this guy here, it's parallel to this? Are we sure that they are not the same? One way to check is check if this point, the coordinates of this point, satisfy this equation. If the coordinates does not or do not satisfy the equation, meaning the x-coordinate and the y-coordinate do not satisfy the equation here, then this point is not on this line, which means this line is different from this line. But indeed, you have here 2, 1. So in here you have 2 times 2 plus 5 times 1. This is equal to 4 plus 5. This is equal to 9. And this is not equal to 1, which means that this point is indeed not on this line. Okay? Question? Now, another term here, perpendicular lines. So in here, two lines on the plane are said to be perpendicular if they intersect at a right angle. Okay? So for example, you have this line here and you have another line here. If this intersection here, you get the angle there, and it's a right angle, it's a 90-degree angle, then these two lines here are perpendicular. The x-axis and the y-axis are also perpendicular. This is your y-axis, this is your x-axis. That's obvious. Your y-axis is vertical, your x-axis is horizontal. So they are perpendicular. Okay? But we will not be talking about angles, particularly this right angle. So the question is, how are we going to determine whether the two lines are perpendicular or not? We use their slopes. Okay? Two non-vertical lines are perpendicular if and only if the product of their slopes is equal to negative 1. Okay? So meaning, say you have your slope m1 and then you have your slope m2. If you multiply them, you must get negative 1. Okay? Equivalently, two non-vertical lines are perpendicular if and only if the slope of one line is the negative reciprocal of the slope of the other line. Okay? That is, if line 1 has a slope m1, line 2 has slope m2, then L1 is perpendicular to L2, if and only if your m1 equals negative 1 over L m2. So negative reciprocal of the other slope. Or you can also have m2 equals negative 1 over m1. Still negative reciprocal of the other. And take note, in both cases, you will have this, m1, m2 equals negative 1. If you multiply this to that side, or this one to that side, you will have this. And therefore, it's the same as this guy here. Okay? Let's look at this example. Find an equation of the line containing the point 2, 1 and is perpendicular to the line to x plus 5y equals negative 1. So these are the same, this is the same point and the same line as in the previous example. But this time we want perpendicular line. So we are given a point, we need the slope, and we will use the slope of this line. We need the perpendicular. Therefore, we have to get the negative reciprocal of the slope of this line. So we already wrote this in the previous slide in slope-intercept form. So y equals negative 2 over 5x plus 1/5. Slope of the given line, so the slope of this line, it's negative 2 over 5. So the slope of the desired line, the one that is perpendicular to this, okay, it's negative of 1 over negative 2 over 5. Negative reciprocal of this, so 1 over negative 2 over 5, and that's the negative outside there. You simplify this, you will get 5 over 2. Okay? Therefore, the desired line, if the desired line contains the point 2, 1, the desired line has equation given by this. Y minus 1 equals 5 halves times x minus 2. Okay? So if we look at this graphically, we'll have this. So this is the given line. It's your 2x plus 5y equals 1. This is the point 2, 1. It's not on this line. Okay? We use this point. We use the negative reciprocal of the slope of this, which is 5 halves. So the line will be this, and you can check this is perpendicular to each other. I mean, they are perpendicular to each other. This is 90 degrees. Okay?